Okay, welcome back to my dear students. So in the last presentation, what we have seen quickly, I will glance through, right? So we have seen the architecture or the conceptual framework of IoT in the previous class, the different types. We started from Relay, then we have seen how it is, purviewed in Oracle, right? So then another frame work, that is from the IBM. Almost each and everything is similar to each other. Then the IBM conceptual framework in the form of diagram, this also have explained, right? So then very importantly, the Cisco framework in the form of layers, which also we refer to it as, can you recall, it is tiers, right? So there are 7 tiers or the 7 layers, which again represent the same thing what we have seen in the case of the earlier frameworks, right? So this is the Oracle, which I have already explained. So gather, enrich, stream, manage, acquire, organize and analyze. Okay, so the Cisco reference model also in the form of figure we have seen, and I had asked you to go through this particular figure. What do you have in the edge, right? What do you have in the node? What do you have in the center? All those things we have seen it from the point of view of the different layers, the pictorial representation. So finally you have a webcam or TV or a sharing or a mobile, whatever it is, right? So a refreshing, you can see all those symbols there. Finally the collaboration and processes, which is going to involve the people and business processes. So all these things are very much essential. So in this way, the 7 layers from the point of view of Cisco reference model we have seen, it's a very important framework, right? So many times when we start designing a system for our IoT, so we may have to refer to this particular reference model. Okay, so in today's class or today's presentation, we shall go to the technology behind IoT, right? So this is another important point to be noted. So what are the different technologies that your IoT makes use of, right? Technology behind IoT. In this case, we will see, as long as the technology is concerned, it is a diverse environment, technological environment, right? So in one or the other layer, so we make use of the different technology here. Okay, so let us start with the hardware. The hardware is a very important thing, right? As I have already told you in the very beginning, so this subject is amalgamation of your coding as well as the hardware, right? We are not concentrating on any of the parts separately, hardware or coding. Togetherly we will have the entire task which is supposed to be fulfilled, that will be realized, right? So when we speak about the hardware, so we start from the embedded devices. Okay, so you know what is the meaning of embedded devices. So if you are very fresh from the knowledge of your microcontrollers, so again go back, what is the difference between microprocessor and microcontroller? That is from where we begin our discussion, right? A microprocessor and microcontroller difference, when the very beginning you must have studied, right? So in the microcontroller, what we have, some of the devices like your timers or could be memories, IO ports and other things, they are embedded into a single chip. Okay, whereas in the microprocessor, each of these are available in the different form. You only have the processor part of it as a chip. The different things which are required as accessories, you need to interface them. That makes the system too complicated for the end user. Whereas in the microcontroller, you have so many things embedded in the single chip, so you are relinquished from the task of interfacing these things. So that is the headache of the manufacturer, right? So that's what we mean by the embedded devices. Many features which are required for you to realize a particular application, they are available in a single chip. They are already in the embedded form, right? So embedded hardware, embedded software with sensors and actuators. We will take some of the examples when we speak about the hardware. See here, Arduino, very familiar to most of you, right? You must have seen an Arduino board. All of you must have seen, some of you must have already worked with the Arduino board. A slightly higher version, according to me, right, is the Raspberry Pi. Raspberry Pi is one of the very versatile type of the hardware that you can have in order to realize your various applications, wherein anyway, I will come to the details of these things later when we come across this in our syllabus. But this Raspberry Pi, it varies in the rate, right, from about 800 rupees, the basic version, up to 3 to 4,000 rupees, if I am right, as long as the rates are concerned. So we can definitely have a Raspberry Pi, and you can realize what you want, what not you want. Everything you will be able to realize, probably with the proper knowledge of one programming language. According to me, it is the Python. Okay. Then you have similarly Intel Edison, Mbed, BeagleBone Black, and Wireless SoC. These are all the trade names, right? Let us not much worry about these things. So some of the hardware aspects which we can see here. Then comes the integrated development environment and software. So what is this IDE, integrated development environment? So these names you should properly know what exactly they mean. Basically, this integrate develop environment refers to software applications, right, that facilitate the programmer for the software development, right? If you want to develop a software, so you can make use of the Visual Studio, right? I think some of you must have heard about the Visual Studio, right? Then you have something called Eclipse, right? You have NetBeans, the different types of the environment under which they facilitate the the programmer to develop a particular software, right? So the names are also given here. You can see here Eclipse, IoT stack. You have something called Sense, ThingsWorks, everything. So everything, you can just see the spelling there. It is not wrongly written, but it is the trademark. Okay, EVRYTHNG. These are some of the the integrated development environments. Then you have the software. No need to mention about what a software is. No need to explain about telling what the software, right? You have got RIoT OS, operating system. This is one small OS which is very popularly being used in the IoT environment. You have called something called ThinkSquare, MIST. You have something called firmware, right? So what is the difference between the software and firmware? Can anybody just recall, right? You know what is software, okay? Software. Then you have firmware. You have one more thing apart from this firmware. You have one more thing which is called as middleware. Please, these names are new to you. These names are new to you, and you please get accustomed with these names, right? Software, firmware. What do you mean by firmware, right? So basically it is as the name itself indicates, it is the permanent software embedded into ROM, right? So generally where you don't need to change these things, a particular application requires a permanent software which is embedded in a ROM of a particular system, that is called as the firmware, right? Middleware, I will tell you as and when it comes. As the name itself indicates, it basically acts as the communication bridge between the two entities, that is called as the middleware. Okay, so software, hardware, and the middleware. Okay, now coming to the next slide, right? So in this particular class, most of the trademark or the trade names you will come across, right? So that is one of our requirements also, right? Then embedded devices and machine to machine communication protocol. So when I speak about machine to machine, it is very important. You have got two machines. How you will be able to establish the communication between the two machines? What are the different protocols that you follow? You know what is the meaning of protocol, right? So the set of rules which a system developer or the system user must follow in order to make sure that the synchronization or the compatibility between the two ends is assured, right? So that's what we mean by protocol. And even in my earlier class also I have told you what is the meaning of protocol. COAP, this is one kind of protocol. It is called as the constrained application protocol. Let us try to see as and when these type of things come, we will look into this, right? HTTP, hypertext transmission protocol, right? So similarly you have so many other things also, TLS, transport layer stream, something like that, right? So these are all the different protocols. Then the communication. So with, as long as the communication is concerned, some of the things are very familiar to you. Okay, RFID I have made a mention, NFC, near field communication, then 6LoWPAN, we will come to that. Zigbee, right? Zigbee is one which is the communication mechanism that is used to connect two devices. Bluetooth, Powerline, Ethernet, LPWAN. So these are all the different communication mechanisms that we generally use in the IoT environment. Okay, anyway, we will come to the details of this as and when they appear in our discussion, and some of the things have already come here, right? So you speak about the network protocol, right? So please go back to your layered approach or the tier approach what we had in the Cisco model, right? So from the physical layer you go to the network layer, then from there you will go to the application layer, correct or not? So as long as the network connectivity is concerned, what are the different types of the protocols that you are going to make use? So you look here, very importantly, Wi-Fi and this one you can see here, right? You are very much familiar with this. 2G, 3G, 4G, 5G. Maybe very shortly we will be in a position to hear 6G also, though we are not yet familiar with 5G itself. Okay, the time will definitely come over the period of time. We will definitely come across these things. Okay, so these are the different network protocols. Depending upon the need, it is not only the internet communication, it is the communication which we establish with other communication modules also. That is the reason why you may have to use multiple network protocols in an IoT environment, right? So you have the Wi-Fi, or you have IPv4, IPv6. These things probably in your mobile network setting and all you must have come across, right? IPv4, IPv6, UDT and all. Okay, then after that we come to the software platforms, very important. Some of you had asked me a question in the very first class. Again I take that point again. So will we have to restrict ourselves to only the software part of it or the hardware also? Now whenever that particular thing is left to you, depending upon what application you are trying to develop, okay, that will decide whether your work will be limited to only the software or you will be able to realize the hardware also. But if you want to realize a typical IoT model, both software and hardware implementations are very essential, right? So now coming to the software platforms, this is called as the inter-network cloud platform, right? So you know what is the meaning of the cloud. So here we have Xively and you have the Nimbits, right? And you have TCS connected universe platform, OpenHAB, right? Then AWS, AWS IoT. You can Google all these things. You will come to know what kind of service they provide and all. So Cisco IoT. So you please look here. I was talking about the Cisco reference model. Accordingly, you have a software platform available from the Cisco also, right? So you have so many things. When you start designing or start developing an application, you will be in a position to choose which one is better, which one is compatible with your selected sensors or the embedded devices. So all those things you should be in a position to understand. Okay, then comes the server. You know what is the meaning of server? I don't think I need to explain what a server is. So basically the server is used for it is acting as a master computer, right? From where all the commands and other things will go to the slave computers. We can call it as slave computers or the slave machines, right? So for the purpose of analyzing and visualizing, right? Analyzing the data, streaming the data, right? Events, streaming the data, right? All those things, right? So at the same time, you can have the descriptive, prescriptive and predictive analysis. I will tell you what is the meaning of this descriptive, prescriptive and predictive analytics. Probably you should be able to understand what exactly is the meaning of the predictive analysis, right? Then prescriptive and descriptive, that I will tell you as and when these things come in our discussion. Data visualization, how do you visualize the data? For the data analytics, it is very essential for you to have the correlation with the data visualization modules. Okay, so these are some of the network protocols and software platforms which generally we come across in the IoT technology. Then analytics and machine learning. Okay, so finally you have now slowly come to the last layer. Please keep that layers in the back of your mind. You started from the basic physical layer, in between network layer and other things you have crossed. Now you have come to the final layer where you have the application layer, right? So here the analytics and machine learning, this is very important nowadays. This is again slightly diversion from what I am trying to speak, right? You must have some idea, definitely irrespective of your engineering branches, you must have some idea on either the big data analytics, machine learning, artificial intelligence, right? So these are the three fields which are going to rule the world in the next decade, next 10 to 20 years, right? Irrespective of your branches, right? You must have some idea and you have got a really very good future if you attain some kind of mastery in these fields. Okay, this is just off the record from whatever I have been teaching. Okay, so analytics and machine learning, learning ability to learn continuously from data and the ability to drive actions, applications, business process. So see, nowadays one more example I will give you. So the business process, right? When I speak about the business process, now it is very similar to the BCCI. You know what is BCCI, right? Board of Cricket Control in India. It is making one MOU with Infosys or TCS or Wipro. You just imagine what could be the reason for a BCCI to. I'm not telling that they have made the MOU. It is a possibility, right? BCCI making an MOU with your software giants, right? Or your Manchester United. Okay, the Manchester United making some MOU with your Redbus or any kind of the software industry, the analytics industry. You just think what could be the reason for these things, right? So this is where the business processes have come to the stage today, right? So everywhere the analytics is very very important, right? So when you play the cricket, right, in the national or international level, there will be a separate wing for the data analytics, right? So how the person bowls, what will be his arm movement, right? Whenever the batsman plays a stroke, right, at what angle he plays, what is his bending, all those kind of analysis they have proven out to be very good input for improvising or countering, right, or making the counter attack. So I think I have to some extent answered the question of what I had asked. Okay, then you have so many machine learning algorithms also. Okay, we will come to these things. Maybe these are not directly relevant to what we are speaking here, machine learning algorithms and all, right? So this is the analytics and machine learning, as long as the technology part of IoT is concerned. Then another important thing, the steps behind IoT, right? How do you proceed in materializing a project or a task under the umbrella of IoT? Okay, so this indirectly I have already told you in the very beginning, but now let us try to channelize these things as per our academic requirements, right? device platform consisting of device and device hardware and software. So you have got some device platform somewhere here. Let us say that here in this you have got the device hardware as well as device software. This is the device platform, right? What are those? Microcontrollers or the customized chips, ASICs. ASICs means application specific ICs, right? So they are not the general ICs, they are the ICs which are customized to serve certain purpose, right? Now for example, you have got a washing machine. In a washing machine, you know the specific task. If it is a fully automatic washing machine, what exactly it is supposed to do, everything will be known to us. So a dedicated IC will take care of that, right? Suppose if that IC goes, it will not be possible for us to resume the operation of that washing machine by some other ICs, right? They are called as the application specific ICs. Like that, there are so many such examples. Okay, so microcontrollers or the custom chips, software for the device API, application programming interface. What do you mean by API? Application programming interface. What do you mean by that API, application programming interface? These are basically the tools that help in creating the software. Okay, you must have heard about the iOS of Apple. Okay, Apple has got one iOS. This is one API of Apple. Okay, so basically they are used to define the protocols. For the purpose of defining the protocols, we use the API. Then from there you go to the connecting and networking. Again, you recall that 7-layer model. So if you are able to bring from backside to the front, so probably the steps also you should be able to correlate. Server and web programming, I will tell you what exactly we mean by the edge computing and node computing later. Again, server and web programming, cloud platform for storing and computing, right? So then comes the data analytics. So probably here also you got about 7 steps, okay, which almost matches synonymously with what Cisco reference model I have discussed earlier, right? So device platform, the microcontrollers, software for APIs and web applications, connecting and networking, server and web programming, cloud platform for storage and computing, and finally the data analytics. This is where the real brain comes into picture, the data analysis, visualization, where you have got this machine learning and other things coming into picture. Okay, so these are the 7 steps that are behind one particular implementation using IoT, whatever the task that you have started with. Okay, so now the same thing which I have explained in the previous slide. So this is basically summary. We need 5 technologies for IoTs, starting from the device platform, okay, then device hardware and software technology, connecting network technology, cloud platform or server, analytics. So some of the steps of the previous slide, whatever I am just showing you, they are here merged. So that gives you a summary here, very important. You start from the device platform, hardware and software technology, connecting network technology, cloud platform or the server, finally analytics, the data visualization or the machine learning. So these are the 5 very important aspects that we need to have whenever we want to implement some project based on the IoT. Now in our subsequent discussions in the later chapter, some of these things as applicable to our domain, electrical and electronics engineering domain, we will definitely discuss based on the similar grounds what we have. Okay, now with this I am coming to the next aspect, that is called as the major components. Now I am speaking about the components. So far we have spoken about the system or the technology, what is required for the IoT. Now slowly we will come back to the components. We are going deep into the IoT scenario now, right? So under the major component of IoT, first we speak about the sensors and control unit. Now this is probably more familiar to you. rather than what I have discussed previously. Many of the computer science related or the network related parameters have come previously, but slowly now we have changed our paradigm from that domain to our domain, which probably to some extent we are familiar with. Okay, so now analog sensors, again go to the first layer or the basic layer there. Analog sensors, thermistors, you know what are thermistors, right? Photoconductors, pressure gauge, hall effect sensor and all, right? Maybe to measure the different analog quantities, light, temperature, pressure, movement, right, displacement, anything, right? So few of them I have mentioned here, and you can have n number of such kind of analog sensors, right? So basically they sense the analog input quantity. And you have the digital sensors. You have the touch sensors, touch screen, proximity sensor. When you go near to a sensor, what happens, you know? Metal sensor, you must have seen them in big malls and all, right? Traffic presence sensor, rotator encoder for measuring angles, linear encoders for measuring positions, whatnot, right? These are the few which I have mentioned. Please remember, the very success of IoT environment very strongly depends upon the kind of sensors. That is the reason why you, along with the measuring the quantities, you also require to have enriching the data, right? So that's what we have seen in one of our earlier IoT frameworks, right? So analog sensors and digital sensors, they are not definitely limited to this what is displayed right in front of your screen. There are many more. Okay, then major components of the Internet of Things system. Under this we have another important thing, RFIDs, radio frequency identification device. Basically it is an identification system, right? So RFIDs are basically confined to identifying something. I have given you the examples of the tigers. I have given you the examples of inventory control, right? Tagging and labeling. I have given you the examples of how the Amazon or Flipkart or Snapdeal tracking takes place. Okay, so tagging and labeling, tiny chips. These are the tiny chips. It could be passive or it could be active and battery powered when reader nearby. Okay, sorry, if there is some problem here, right? So when reader is nearby, we have to stop here, okay, in this point. Okay, these are the passive or active or battery powered when the reader is nearby. Wireless communication range is about 10 centimeter to 200 meters. You just see the range is really good here, 10 centimeter to 200 meter. And for this RFID devices, the standard frequency ranges are, you know, 120 to 150 kilohertz. Okay, then you have, one second, there is some issue here, 120 to 150 kilohertz, 13.56 megahertz, 433 megahertz, and higher in UHF, ultra high frequency, and microwave regions. These are the standard frequency ranges which we for the time being need not worry much about it. Okay, the RFID devices are very important devices here. These are basically for the identification purpose, right? And what for you are using the RFIDs? As I have already told you, tracking and inventory control, identification of supply chain system. Get back to the example of your Amazon, right? Access to building and road tolls, correct or not? Okay, then secured store center entries, right? You must have seen in big malls and all, right? So devices such as RFID based temperature sensors, you may have the temperature sensors, right? Application in factory design, there are so many such applications, right? Anti counterfeiting, I will tell you about all these things. Business process for payment, leasing, insurance, and quality measurement and quality management and all. So these RFID devices basically serve as one of the major components, right, which come under your sensors, as we can see here, right? So RFID devices. Now from this we will next move on to WSN. So what do you mean by WSN? wireless sensor node or wireless sensor network, right? It is defined as a network in which each sensor or node connects wirelessly without any wired connection. Each node is going to connect to the other node, right? They have also the capabilities of the computation, right? Data compaction, aggregation and analysis. Please look into these words. These are very, very important, right? So for the purpose of compaction, I mean making the data compact, what you call as compression, right? Aggregation, right? And for the purpose of analysis, you use this WSNs, each with communication as well as networking capabilities. Each WSN will be having both the capabilities of the communication as well as networking, right? So you have the node characteristics. Autonomous nodes, they are autonomous, independent computing power and capability to send requests and receive responses, right? Capability to send the request and receive the responses, and also data forward and routing capabilities. When we take up that diagram, so we will come to know where exactly this WSN comes and all. And probably if you go back to one of the reference models that we have taken earlier, could it be IBM or Oracle, somewhere I think you have you should be able to find this WSN. There you try to correlate the working of the characteristics of WSN and how exactly it makes its sense in that particular diagram. Okay, so this is about WSN. So now I have just crossed my time limit of 30 minutes. So with this I will stop here. So if you have any doubt on whatever we have discussed so far, as long as this technology behind IoT is concerned, right? So please get back to me in my Google Meet, just which is going to start shortly from now. Okay, so we will stop here. We will go to the next thing in our next presentation.